Figure 1 shows an arrangement of 3 lines with 1 intersection point, and Figure 2 shows an arrangement of 3 lines with 3 intersection points. What is the maximum number of intersection points that can appear in an arrangement of 4 lines? So let's just use Figure 2. Figure 2 has currently 3 lines, right? So let me add a 4th line and see what happens. And in a way, I want to maximize the number of intersection points. So the way I'll do that is by maximizing the number of times I cross with that 4th line. So let me see, how am I going to do this? Let's see, something like this. Yeah. So that 4th line that I just drew crossed the other 3. So the total number of intersection points, there's 1 here, 2 here, 3, 4, 5, and 6. So 6 is the way to do it. And therefore number 11 is D. The numbers 5, 6, 10, 17, 21 are rearranged so that the sum of the first 3 numbers is equal to the sum of the last 3 numbers. What number is in the middle? So this requires a little bit of playing around. Let's just put the big ones at the ends, and then what number should I put here, and then eventually I'll get the middle one. Okay, well, those 2 are gone, so I want the sum of these 3 to be equal to the sum of these 3. Okay? Well, these 2 numbers differ by 4, and these 2 numbers differ by 4. So if I can use that fact, I'll be able to deduce that the 10 could go here, and the 6 could go here. And that way, that sum is 27, and that sum is 27. So therefore, the other number would go in the middle, and that number was 5. And then you can always figure out the sums of those 3 and the last 3 are going to be 32. So everything works out, and therefore number 12, the answer is A, 5. For some integers m and n, the expression x plus m times x plus n is equal to the quadratic expression in x with the constant term of negative 12, which of the following cannot be the value of m. Let's expand that first, and let's see what we get. So we get x squared plus xn plus xm plus mn. So the constant term of minus 12 is referring to this guy. So that means that mn is equal to minus 12. So m and n, if we make a table, let's see what we can get. Well, did they give us any conditions on the m and n? I don't think so. Okay, well, it could be, let's just look at the answer choices. Could m be 1? If the answer is yes, then that's a negative 12, because we want m times n to be negative 12. Could it be 2? Then that would be 6. Could it be 3? Yes, that would be 4. If it's 4, it would be negative 3. 5, no, because then that would be minus 12 over 5, and that is not an integer, because both m and n are integers. So therefore, m cannot be 5, and therefore the answer to number 13 is E. In diagram, point C is on side BD of quadrilateral ABDE. Also, AB and ED are perpendicular to BD. ACB is 60. CAE is 45. AEC is 45. If AB is root 3, what is the perimeter of quadrilateral ABDE? Okay, so a bunch of chasing here, angle chasing and side chasing. Well, this is 90 right here, and that's 60. So this is going to be 30. And the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3. That's the ratio. But they actually tell me that AB is 3, the actual value. So if the actual value is root 3, then the other sides, the actual values are 2 and 1. So that's done. And then that's 45 and that's 45. So therefore this must be 90, and that's a right angle. So that's isosceles, so that means that is the same as that, so that's 2 also. Okay, so this angle in here, what's going to be 180 minus that 60 minus that 90, so that means that's 30. And since that's 90, then that's 60. And again, the ratio of the sides of a 30, 60, 90 triangle are 2, 1, and root 3. And since that side was already 2, that was sides, the actual length is 1 and root 3. Okay, so we're almost done. We just have to figure out this AE. AE using Pythagoras will be 2 squared plus 2 squared, which looks to me like 8, and therefore AE is 2 root 2. We take the square root of that. So now for the perimeter, therefore, of that whole thing would be root 3 plus 1 plus root 3 plus 1 plus 2 root 2, and therefore it would be 2 plus 2 root 3 plus 2 root 2. And that looks to me like choice E. Anila's grandmother wakes up at the same time every day and follows the same routine. She gets her coffee 1 hour after she wakes up. This takes 10 minutes. She has a shower 2 hours after she wakes up. This takes 10 minutes. She goes for a walk 3 hours after she wakes up. This takes 40 minutes. She calls her granddaughter 4 hours after she wakes up. This takes 15 minutes. She does some yoga 5 hours after she wakes up. This takes 30 minutes. If Anila's grandmother woke up 5 minutes ago, what will she be doing in 197 hours? Okay, hours. 197 hours. Well, it looks like every day she has the same routine. So every 24 hours, which is a day, it'll be exactly the same. So how many 24-hour cycles is that? 24 times what? I think 24 times 8. And then you're still going to have 5 hours left over. So these guys, it'll end up at the same point. And then we just have to figure out after another 5 hours. So let's make a number line or whatever. So this is where she wakes up. Coffee after 1 hour. So this is 1 hour. And then what's the next one? Shower after 1 hour. So this is 2 hours after she wakes up. So 3 hours after she wakes up, she goes for a walk. So that's another 1 hour. 4 hours after she wakes up, she calls. So she calls. That's another 1 hour. And 5 hours after she wakes up, she does yoga. So this 5 is 5 hours, not really after she wakes up, but 5 hours, 5 minutes after she wakes up. You got to read the question carefully. So basically we're going from approximately here, 5 hours later, which would be approximately here. And it looks like at that point she's doing yoga because she does yoga for 30 minutes. So she'd be doing yoga till the 30-minute point. So at that point, she'd be doing yoga, and therefore number 15, the answer is C. Francesca put one of the integers 1 through 9 in each of the 9 squares. No integer is used twice. She calculated the product of the first 3 integers in the row and wrote the products to the right. She calculated the product of the integers in the columns and wrote the products below. Finally, she erased the integers. Which integer is n? All right, so this is a whole bunch of trial and error. So let's see what we can do. And hopefully we can do it quickly. So let's concentrate on this 21. That means I'm just going to label it really quickly. You don't really need to, but it just makes it a little bit easier for me. G and H, whatever letters you want to use. So that means A times D times G is 21. Now 21 is actually 3 times 7. Those are primes, so that looks like there's got to be a 1 in there. Okay, so now that doesn't really help me which one is A, which one is D, which one is G, but let me just concentrate on at least one, on 7, for example. Wherever I put 7, that has to eventually be included in those products. So which one of those is actually divisible by 7, right? That's the way I'm looking at this. Well, 56 is divisible by 7. Because 135 and 48 are not. So 7 has to be here. Because 21 is divisible by 7 and 56 is divisible by 7. So that's sort of the strategy. And as you can see, this is going to take a little bit of time, but hopefully we can do it pretty quickly. The next one, it doesn't really matter which one you want to concentrate on, but I like this one here, the 160. Why? Because it's divisible by 5, and you can clearly see that it is. So 160, which is actually 5 times 32, which is 5 times 4 times 8, because remember, we're only limited to those numbers, so we have to make whatever number it is break down into 3 numbers from that list. So I'm pretty confident that the 5 goes somewhere in the CF or H, but which one, I'm not sure. But then I have to look at these guys. Which one is, let me concentrate on 5. Which one of these is divisible by 5? Well, it's clearly the 135. So therefore that has to be the 5. Okay, we took care of the 5. And you kind of keep going like this. So if we keep going, let's see, the 135, what is that? That's 5 times 27, which is 5 times 3 times 9. Now in that row, we've already put the 5, so we have to put the 3 and the 9. One of them is D, one of them is E. But remember, this guy had a 1 and a 3, so that means this has to be the 3, because it has to be common to the 21 and to the 135. And therefore, by process of elimination, that E is going to be the 9, and then the G is going to be the 1. So we are doing quite well. Let's see, how many did I get there? Okay, so I've got a few more. Now the rest should be fairly straightforward. Like, for example, the 56 is 7 times 8, right? And that looks like 2 and 4 to me, because the 7 has already been included. Now we just have to figure out which one is the 2 and which one is the 4. Where does it go? 108. The 108, we've already have a 9 in there, so it's 9 times something, right? So 9 times 12, which would be 9 times 3 times 4, perhaps. But the problem is we can't, because the 3 has already been used. So the 9 times 12 could therefore be 9 times 2 times 6. That's good. So therefore, the 56 has a 2 and a 4. The 108 has a 2 and a 6. So the B has to therefore be the 2. And therefore, that means the N is the 6. And if you want to complete the table, the C will be the 4, and then the H will be an 8. And so it all works out. So therefore, the N is the 6. And it took a little bit of time, but it's actually not that bad. So the answer is C. Each of the variables A, B, C, D, and E represents a positive integer with the properties that B plus D is greater than A plus D, C plus E is greater than B plus E, B plus D is equal to C, and A plus C is equal to B plus E. Which of the variables has the greatest value? All right, well, it looks to me like B plus D is greater than A plus D, so that just becomes B is greater than A. Yeah. And then the next one, C plus E is greater than B plus E, so that just becomes C is greater than B. So C is greater than B, and B is greater than A. Okay. That's what I have so far. And then B plus D is equal to C. So that means that C is greater than D. Yeah, C is greater than D. Since everything's positive and C is equal to B plus D, then C has to be greater than D, since B is a positive number. And the last one, A plus C is equal to B plus E. Okay, that one, let's see here. If I put A and E, or A and B, let's see, on one side, and E and C on this side, and then since B is greater than A, B minus A would be, or sorry, A minus B is what I really should be looking at. A minus B would be less than 0. So this is less than 0. Less than 0. And therefore that is less than 0. So if that's less than 0, E minus C is less than 0, that means E is less than C. So C is greater than E as well. So C is greater than B, A, E, and it's also greater than D. So it's greater than everything, so therefore C is the greatest. Suppose that x and y are real numbers that satisfy these two equations. What is the value of x times y? Okay, 3x plus 2y is equal to 6. If I square that, 3x plus 2y times 3x plus 2y. The reason I'm squaring it is because I've got a bunch of squares in there, so I want to get something that has squares in it. That's going to be 9x squared plus 12xy plus 4y squared is equal to 36, correct? And what? This and this is 468, so that's 468 plus 12xy is equal to 36, and therefore minus 12xy would be 468 minus 36, which is 432, and then divide through by negative 12, and you'll get x equal to minus 36. And I think that's it. Yeah. So number 18 minus 36 would be choice A. Three standard six-sided dice are rolled. The sum of the three numbers rolled S is determined. The probability that S is greater than 5 is closest to. Any probability question is usually a fraction. It's the top over the bottom. This is the total possibilities, and this is our specific condition. So the total, well, you have three dice. So each die has 6 faces. So when you roll the first die, you have 6 possibilities. When you roll the second die, 6, and the third die, 6, and you have to multiply that. So 6 to the power 3 would be the total. So now we have to figure out the numerator, which is our specific condition. Okay, or conditions rather, whether there's more than one. But it looks like there's only one condition, which is that the sum has to be greater than 5. Okay. Okay, since these values are very high, that means that there's a lot of calculations. So let me first calculate the sum that it's less than or equal to 5. Correct? And then I can just take the complement. That number is a lot smaller because it'd be 1 minus these guys. I think that's the right approach. Okay, so sum of less than or equal to 5 basically means a sum of 5 or 4 or 3. And I think 3 is the smallest, right? Because if you roll 1, 1, 1, you'd get the sum of 3. Okay, that's the only way of getting a sum of 3. 4, 1, 1, 2, 1, 2, 1, or 2, 1, 1. That's the sum of 4. Sum of 5, 1, 1, 3, 1, 3, 1, 3, 1, 1, or 1, 2, 2, or 2, 1, 2, or 2, 2, 1. Yeah. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 over that, which is 10 over what's 3? 6 to the power 3 is what? 216? This is the probability of the sum being less than or equal to 5. Now we want the sum to be greater than 5, so we take the complement, which is subtracting that from 1. And that, when you crunch that out in your calculator, it will be 0.9537, and therefore the closest is B. A cylinder contains water. A solid cone with the same height and half the radius of the cylinder is submerged into the water until the circular face of the cone lies flat on the circular base of the cylinder, as shown. Once this is done, the depth of the water is half of the height of the cylinder. If the cone is then removed, the depth of the water will be what fraction of the height of the cylinder? All right, so let's explore this. So initially they're saying it's half, right? So approximately here. So I'm just going to call that h, that height. And therefore the total height will be 2h. All right? And then the radius, there's a couple radii. There's the radii of the cone and then the radii of the cylinder. And they're saying that they're half of each other, correct? So I'm going to give some numbers. It just makes it a little bit better instead of having a lot of letters. So the small radius is half of the big radius, right? So I'm just going to let the big radius be 12, and that's the radius of the cylinder. It doesn't really matter what you label it. And then for the small r will be 6, and that's the radius of the cone. Okay, and they've been very nice and given us volume formulas. Pi r squared times height, and the volume of the cone is pi 1/3 pi r squared times height. Okay, so the volume of the water is very interesting. Is that I'm going to draw it separately here. I don't want to make the diagram too messy. You notice the only part that's submerged is sort of half, not even half, but it's like you've cut off the top. you've cut this part off and you're just looking at the bottom. So that is the volume that I'm interested in. So that volume is the volume of the full cone, which would be 1/3 pi. Radius of the cone is 6 squared times height, but the height is this guy, the full 2h. And then you have to subtract from that this top part. So that's going to be 1/3 pi sum r squared and then times h. Okay, now I got to figure out what is this r. See, this r is 6, but what's that r? I think I can get that through similar triangles. Since that's h, and that's 6, that's a right angle, that's a right angle, and we'll just call that x. That means h over x is the same as 2h over 6. So that means if the h's go, 1 over x is equal to 1 over 3, so therefore x is 3. So that 3 goes there. Okay, so therefore if I crunch out these numbers, I will get, let's see here, 36 divided by 3 is 12. 12 times 2 is 24. So 24 pi h. And then this one looks like 3 pi h. So therefore 21 pi h is the volume of that bottom part. Okay, so far so good. The volume of the water is basically this stuff, right? Not counting the part of the cone. So you would take the full volume, so the volume of the water is the full pi r squared h of the cylinder, but you have to subtract from it that cone segment that's submerged. And that cone segment that's submerged, we just figured out was 21 pi h. Got it? So that the cone part, the cone's volume will be calculated with its radius, which I believe was, sorry, what am I saying? The cylinder. This is referring to the cylinder. Sorry about that. This is the cylinder. The cylinder's radius is 12 from up there. So 12 squared. And then its height is h. And then this is just the 21 pi h that we calculated here. Okay, so that should be 144 pi h minus 21 pi h. And that is 123 pi h. Okay, so that is a very important calculation. And then now the final step, of course, is to figure out what is the height when that cone, when this cone is removed. Then the volume will actually, the volume of the water is the same, but then the height goes down because the volume, like, how do I draw it here? Let me just say, like, this is the cone. And initially the volume was here, but then once that cone is removed, the volume of the water will go down a bit. It'll be here, let's say. So they're saying figure out that length or height or whatever. Okay, that can be done pretty easily. We just have to take this volume and use the volume formula for the cylinder. So right there. So pi r squared h is 123h, pi h I should say. The pi's cancel, and therefore r, what r are we using? We're using 12, correct? We're using the actual radius of the cylinder. So that's going to be 12 squared h is 123 big H, and therefore that's 144 h. This is the small h, by the way, in case you're wondering. 123 h, and therefore the ratio would be small h over h would be 123 over 144. So that means that, for example, if the big H is, say, 144 and the small h is 123. Okay, now but what they're asking for, the final step, is how does this compare to the full height? So if h is 144, the full height, which is 2h, would be 288. and therefore that comparison is between the 123, which we just calculated for the small h, over the full height, which is 288. And that is what they're referring to. And in lowest terms, that comes down to 41 over 96. 41 over 96 is the answer, and that is B.